What we're going to do now is we're going to talk about the converse of the Pythagorean theorem, go into a little more detail than we've done before, and explain exactly what this converse means. Converse is something is where we take the hypothesis and make it the conclusion, take the conclusion and make it the hypothesis. So the Pythagorean theorem states that if there is a right triangle, then the square of the hypotenuse equals the sum of the square of the legs. Okay? So we're going to take that and turn it around, and this is what it looks like. We're going to take that conclusion of the Pythagorean theorem and make it the hypothesis, and we're going to take the hypothesis and make the conclusion. So that would be the converse. And it states, if the sum of the squares of two sides of a triangle equal the square of the measure of the longest side, then the triangle is a right triangle. Okay? Pretty simple. Basically, it's just saying, hey, if there's three numbers, and we use the longest to represent what might be the hypotenuse, and we stick it into the Pythagorean theorem, and it equals, you got a right triangle. It's a way to see if three numbers will make a right triangle. So what we've got here as a sample is I've got three numbers here, and we're going to see if they will make a right triangle. We take the biggest number, the longest or the biggest, and we're going to square it. We're going to use it as representative of C of the hypotenuse. So 17 squared equals 8 squared plus 15 squared, and we're going to see if that's true. 17 squared is 289. 8 squared is 64. 15 squared is 225. Add those up. Wow, 289 equals 289. Since that's correct, this is a right triangle. So these three numbers right here will create a right triangle. Now let's take another one. 7, 12, and 20. Let's put them in to Pythagorean theorem. Obviously, the longest or the largest is going to go where C would go. And so we have 20 squared equals 7 squared plus 12 squared. 20 squared is 400 equals 7 squared is 49. 12 squared is 144. 400 equals 193. That doesn't work. So this is not a right triangle. Okay? That one doesn't work. And that's basically what the converse does, is it lets us take three numbers and determine whether or not they are a right triangle. Now, what I want to do next is show you a little bit of something different about this converse. Now let's look at a little bit different way of using Pythagorean theorem. Same converse. Here is the regular Pythagorean theorem. C squared equals a squared plus b squared. And when this is true, when c squared does actually equal a squared plus b squared, we have a situation like this. Point C is here. It's a right angle. A is here. Point A and point B is there. Okay? Now then, let's look at this situation where we've got this. Where c squared is greater than the sum of a squared plus b squared. When that happens, let's draw this over here. Here we've got little c, little a, and little b. Over here we've got little c, little a, little b. And let's do this, little c, little a, and little b. So when that happens over here, what we've got is c is longer than it needs to be for a right triangle. And what happens is it spreads those a and b apart. And what happens is you now have a what kind of triangle? You have obtuse. Okay? You now have an obtuse triangle. So from using this, we can tell what kind of triangle it is. If it's not a right triangle, we can tell. And vice versa, the same thing happens if c squared is less than the sum of a squared plus b squared, then what we have is, we have a what kind of triangle? An acute triangle. Because why? That angle closes up and, okay, C is smaller, so it closes that angle up, and as a result, we have an acute triangle. So there's multiple ways, a little bit different way to use Pythagorean theorem. All right, now we're going to look briefly at what a Pythagorean triple is, and then go into some samples. Okay, we're going to talk about something called a Pythagorean triple, and we mentioned it in a couple of the clips, and so let's get into it and really go for it. Now, Pythagorean triple has to have two things have to be true. Pythagorean triple is three numbers that first of all satisfy the Pythagorean theorem. In other words, c squared equals a squared plus b squared, or a squared plus b squared equals c squared. Okay, that has to happen. And they are positive whole numbers. Okay, so let's go over here and try some. Now, let's try this. That would be 5 squared is 25 equals 3 squared is 9 plus 16. So that's 25 equals 25. So that happens. Now, are they positive whole numbers? Yes. Is that a Pythagorean triple? It sure is. Okay? Now let's look at this. 2, 5, and 8. 8 squared is 64 equals 2 squared is 4 plus 5 squared is 25. Does 64 equal 29? No. Do we have to do anything else? Well, they are positive whole numbers, but they have to do both, so this is no, they are not. Why? Because they do not satisfy Pythagorean theorem. Now, let's look at 5, 12, and 13. 13 is a big one. 13 squared is 169. Okay? 5 squared is 25 plus 12 squared is 144. Add those up. Does 169 equal 25 plus 44? Yeah. So does it satisfy Pythagorean theorem? Yes, it does. Are they positive whole numbers? Yes. Are they a Pythagorean triple? Yes, they are. Now let's look at these. Oh, 5, 12, and 13. Divide those each by 10. Are they going to satisfy Pythagorean theorem? Yes, they are. We don't even have to do it. We can come back here and look at this, and we're going to get 1.69 equals 1.69. It's just that simple. Okay? I think so, yeah. But are they positive whole numbers? No. So are they a Pythagorean triple? No, because they're not positive whole numbers. Here's another one, 3, 4, 5. We know that 3, 4, 5 satisfies that. So if we just simply divide all those by 4, what are we going to get? Well, 9 sixteenths plus 16 sixteenths. Does that equal 25 sixteenths? Well, 9 plus 16 is 25. Yeah. So yes, this satisfies that. But are they positive whole numbers? No, they're not. Are they a Pythagorean triple? Let's try this. What if we had negative numbers? They wouldn't satisfy, would they? And that's what a Pythagorean triple is about. Has to satisfy these two conditions.